All right, so I'm going to give us some more code to start for our next homework assignment. So we're going to write some stuff that'll be like the first half of your next homework assignment, but we're going to start talking about another data structure here. Talk about something called a stack.
I already
Okay.
watched that.
Stack? Okay, so a stack data structure, think of this like a stack of magazines. Okay? So when you're adding things onto a stack of magazines, you always put, you have the next magazine, you put it on top of the magazines that are already there, right?
Okay.
When you remove a magazine from the stack, you take the top magazine. Otherwise, if you take something from the middle, the stack falls over, right? So a stack is a last in, first out queue. So the last thing you add is the first thing you remove. That makes sense? A stack must implement the following functions. Pop removes the element from the top of the stack and returns it. Peek returns the element from the top of the stack, but does not remove it. So it allows you to look at the top of the stack, but doesn't actually remove the value from the top of the stack. And push adds an element to the top of the stack. That make sense? So those are the three functions that a stack must implement. Push, pop, peek. We push something onto the stack, we pop something off the stack, or we can peek at the top of the stack to see what's there without actually removing it. Okay? That's what a stack does. What I'm going to go ahead and do here is we're going to implement a stack data structure. Create a new class. Call this guy a stack. And we're going to say stack extends linked list. A stack is a linked list. Pushing something onto a stack is adding to the front. Removing something, popping something from the stack, is removing from the front, right? And peeking is getting the element at bucket 0. Does that make sense?
Yeah, peeking is like just searching from the stack.
Not searching. It only lets you look at the top. So if you have a stack of magazines, peeking would be equivalent to you just leaning over and looking at the top magazine. You could even flip through it, but you wouldn't actually remove it from the stack. So peek would give us that magazine, would give us that node, but it wouldn't remove it from the stack. So peeking lets us have access to it, but doesn't remove it.
So just it will tell the where is the position, but we can't able to remove it.
It lets you see the thing at the top of the stack, but doesn't remove it from the stack. So the final state of the stack would be the same as it was beforehand. Popping, though, actually removes the top element from the stack and returns it. Peeking gives us access to the top element from the stack, but does not remove it. Pushing pushes something onto the stack, always onto the top. So we're going to implement our stack in terms of our linked list. So we're going to have public stack. This guy's going to take no parameters. And we're going to call upon our parents constructor. That's where we say super. Just as a reminder there, here's the linked list constructor. Takes no parameters and sets the head and the count, all the crap it's supposed to set. So super says, call my parents constructor to do the initial setup. Because really, a stack is exactly like a linked list. We're just going to provide specific functions for push, pop, and peek. And we're actually implement them in terms of functions that are already there. Okay, so public stack, that's a constructor, and he's going to get built the exact same way as a linked list does. So we just call upon super, our parent, because this guy is a linked list. So we're going to have public void push. Push is going to take in an integer value. Let me go back here to our linked list. It's going to take an integer value just like our add methods do. Added index takes in an int and it builds the node out of that.
Okay.
Okay, so this guy will take an int value for push. And what are we going to do with it? We're going to say this dot add front value. That's what pushing does. This guy has an add front method because he is a linked list. So a stack has a method named push, but all that push does is add to the front of a linked list.
I have a question. What
Yep.
super gets where it gets that rules from the previous like linked list?
Yes. Stack, since this guy extends linked list,
Okay.
our parent is a linked list.
Okay, I get it.
Super is how we access our parent.
Okay.
And this is the special syntax for calling our parent's constructor. If you're going to use your parent's constructor to at least partially initialize a variable, it must come first inside of the stack, inside of the constructor. Okay. So then we have public node pop. This guy will return this dot remove front. Because pop actually removes something from the front, right? And then we'll have public node peak. And we're going to return this dot get 0. Okay, and this guy potentially can throw an exception. So we'll go ahead and here we'll just say throws exception. All right, so now notice how easy this looks in here. Because we already spent the time building our linked list, a stack is really easy to implement, right? All the functions of a stack are functions that we already wrote into our linked list, okay? But stacks are a simpler data structure than linked lists. We're going to have to rewrite stacks on our own here in a few minutes. Why? Because I'm going to give us our setup for writing our our programming assignment. Okay? But in any case, let's go test this and see how it works. Whoop. Back to driver. Stack S is equal to new stack. S dot display, and we'll see we currently have the empty list. Let's go ahead and say S dot push 1. S dot push 2, 3, 4. Okay, so we are pushing these values onto the stack. So we'll push 1 onto the top of the stack. Then we'll push 2 on top of that. Then we'll push 3 on top of that. Then we'll push 4 on top of that. Okay? So our stack should look like 4, 3, 2, 1.
Goes from down to bottom.
Because we're always putting it on top. When we push onto the stack,
Okay.
we're putting the magazine on top of the stack.
Okay.
That makes sense?
Mm-hmm. So
If we say S dot pop, now a value flew out of here. I chose not to use it, but push 1, push 2, push 3, push 4, pop should pop off for the 4. The last thing I pushed will be the first thing that pops. So I should be left with 3, 2, 1. Similarly, if I say S dot peak, I'm still left with 3, 2, 1. And let me show you why real quick. I'm going to say node n is equal, that's fine. Node n1 is equal to that. Node n2 is equal to that. So we'll go ahead and do a system.out. Well, here we don't even need to do that. We can say n1.display and n2.display. So we're going to see that when we say s.pop here, we will pop the node off the top of the stack, actually physically removing it from the stack, and we'll return that value, storing it inside of n1. So n1 should be a 4. The last guy we pushed is the first guy that pops. But then we do a peek, and we store that in n2. Peek will give n2 the new top of the stack, which will be our 3. But our stack will still have 3 in it. We didn't actually remove the 3. So we should see our entire stack after the pop, which should be 3, 2, 1. Then we should see the 4 that we removed. Then we'll see the 3 that we peeked. Okay? 3, 2, 1. So we saw that the peek did not actually remove it from the list. Here's the 4 that we indeed popped off the list. And here's the 3 that we peeked. Notice that it did not actually remove it.
Okay, just
Yeah, lets you have access to it, but doesn't remove it from the stack.
okay.
Make sense? Okay. Questions about stack data structure? No, pretty simple, right? Okay. Now, how many of you have heard of the game Towers of Hanoi? Okay, well, we're going to write it. All right? By we, I mean you. Okay? I'm going to give you a starting point for it. First of all, the second I say write a game, everybody thinks it's harder than it is. This is not that difficult. So I'm going to show you, if you've never seen it before, how to play it. For your assignment, you're going to be writing literally a mimic of what we have right here. That is, there's 3 separate towers, and we have 3 disks to start off with. So the goal of Towers of Hanoi is you have, there we go. There's a power saver thing, I guess. We have 3 disks here. A big one, one a little bit smaller, one a little bit smaller, stacked on top of each other. Okay? Our goal is to get these 3 disks on this last tower. Okay? We need to have them travel over to this last tower. But the rule is you can never have a larger disk on top of a smaller disk. Okay? So you need to use these towers in order to, so we're going to take this guy and we're going to put him here. Now, if I take this guy and I try to put him here, it's not allowed because this is a larger disk being put on top of a smaller disk. Yelled at me. So I'll take this guy and I'll put him here. Then I'll take this guy and I'll put him here. And I'll take this guy, put him here. This guy, put him here. Actually, put him here. This guy, put him there. Put him there. Put him there.
Oh, I did it in 10 moves. I'll take that.
All right, that makes sense? How it works?
Yeah.
Everybody understand the premise of Towers of Hanoi? Okay. This is a stack. Okay? Each one of these towers is a stack.
Okay.
It's a stack of disks. What's a disk? A disk has a size. So if we say this is size 3, and this is size 2, and this is size 1, we know that we can't, so if I got to start over. How do I reset? So I just popped. I popped from this stack and pushed onto this stack. Make sense?
Mm.
Then I'm going to pop this guy off this stack. This is my node. My node in this case is actually a disk. But I cannot push onto this stack because he has a rule. You cannot push a disk onto the top of a stack where the current top element is smaller than the disk you were putting on there. So if we were to peek at this guy, we'll see that his size is 1. The guy I just popped here has a size of 2. I cannot put it here because upon peeking, I noticed this guy is too big to put on top of this guy. Make sense? So I'd need to put him over here. So understand how we're using these like stacks? So really a disk is just a size. That's all we need to know about a disk is a size. So we're going to go ahead and we're going to create that object. Let's see. I'll leave all this code in here. So I'm going to create a new class. We're going to call this guy a disk. Okay? And the disk is going to have a private int size. And creating a disk just has us create the size of the disk. So we're going to say we'll have 3 different size disks. If you notice over here in our Tower Hanoi screen, typical towers of Hanoi will allow you to have more than 3 disks. For our implementation, you only need to allow it to do 3. But hopefully we'll see it would be no big deal to do more than 3 because we're writing a generic disk object that we just pass it the size. So we could have a size of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, blah, blah, blah. But for your assignment, you're only going to have to write it with 3 disks. Okay? So the disk is going to have a size. We're going to then have a method called getSize, and this guy's going to return this dot size. And then we're going to have a method called toString. This guy's going to return a string. This is so this guy will work with the println method. And what we're going to do for our disk is if it has a size of 1, it's going to display a single equal sign. Size of 2 will be 2 equal signs. Size of 3 will be 3 equal signs. Make sense? Okay, we're actually going to change that here in a minute, but just for starters. So I'm going to have this guy return. It's going to return a string that is this many equal signs. So I'm going to create a string called answer. Start off as the empty string. For int I is equal to 0, I is less than this dot size, I plus plus, answer is equal to answer concatenated with equal sign. That's going to be our awesome graphical representation of our disk. Okay? So, and then ultimately we'll return whatever answer is. All right? Let's go ahead and test this out in driver. Oh, that's a funny typo. Disk D3 is equal to new disk 3. And then we'll do a system.out.println D1. And then we'll do the same thing for D2 and D3. And there's our 3 disk sizes. That make sense?
Okay.
All right, now, realistically speaking, we probably want to have this guy look more like a tower.
Okay.
Right? Which means that a disk size of 1 our tower might look like this. Would that be an acceptable tower? If it looked like that? So if the size is 1, maybe 2 equal signs. The size is 2, 4 equal signs. The size is 3, 6 equal signs. So depending on the size, just multiply it by 2. That makes sense? So let's go into disk. So we'll say this dot size times 2. But the problem is they'll still be left justified.
Oh, okay.
So really we need some spaces in front to make it really look cool. The cool text-based Tower of Hanoi, right? So how many spaces are we going to have in front of this guy?
1.
Let's go back here to driver. So 2 spaces, 1 space, 0 space.
Mm-hmm.
Does that make sense? So how do we mathematically do that?
Print and display D1 1 space D1.
And we put this string.
This was 0, this was 1, this was 2. Correct? Okay. If we had more disks, so let's say we had one that was even bigger than this guy. So 2 bigger. This would be 1, this would be 2, this would be 3. Does that make sense? Okay, so if we leave it up to the stack itself, the tower itself, to be able to display its disks. I want to write this generically because next class, when we show you the solution, we'll also build this out to work on multiple disks. So what we're going to do is we're going to leave disk alone. This guy currently returns the appropriate number of equal signs. And we're going to create another class called tower. What is a tower? It is a stack of disks. Make sense? So we're going to create a new class called tower. And tower is going to be a stack of disk objects. But more importantly for us, this tower, we'll say, for right now, just so I can, I'm just trying to think what's the best way to make this easy for you to do your homework. I'm going to create a disk array. So this goes back to our discussion about linked list versus array. I'm going to create a disk array called the disks. And here's our public constructor for our tower. Now, this guy is going to always create a tower of size 3 for our homework assignment, so I won't make him take any parameters in. So we're going to say the disks is equal to a new disk array 3. Okay? And then what we're going to say is we're going to say the disks at bucket 0 is equal to a new disk of size 1. The disks at bucket 1 is equal to a new disk of size 2. the disks at bucket 2 is equal to a new disk of size 3. Okay? Then we're going to have our display method. Okay? We'll have our display method. What's the display method going to do? It's going to go through and it's going to display our disks. Now, I know that my array has 3 elements in it. And getting back to what we had out here with our drawing, if our array has 3 elements in it, the very first guy will have 2 spaces. The next guy will have 1 space. The last guy will have 0 spaces. So for displaying, we're going to have an int num spaces, and this guy will start off as this dot the disks dot length minus 1. Make sense? And what we want to do is when we display a disk, we want to pad it with this number of spaces. So when we show the very first disk, the 1 size disk, we'll put 2 spaces out front. Then we'll put 1 space in front of the 2 disk. We'll put 0 spaces in front of the 3 disk. So as we go through here, for int I is equal to 0, I is less than this dot the disks dot length I plus plus. So we'll go through all of our disks. The first thing we're going to need to do is we're going to need to pad. That make sense? We're going to pad our spacing. So we're going to go ahead and we're going to say for int j is equal to 0, j is less than num spaces, j plus plus, system.out.print, not println, print a space. Okay? So that'll put a bunch of spaces before it. Then we'll do a system.out.println this dot the disks dot or the disks at bucket I. That'll print out the right number of elements. So for the 1 disk, this will give us 2 spaces, followed by the 2 equal signs. Next time through, num spaces will be 1 smaller than it is now. For the 2 disk, it'll be 4 disks with 1 space in front of it. For the 3 disks, it'll be 6 equal signs with 0 spaces in front of it. So out here in driver, we'll create our tower t is equal to new tower, t dot display, and we see we have, after I remove my drawing, we have a perfectly displayed tower.
Okay.
But wait, there's a problem. I just displayed 1 tower. How many towers are in the game of Hanoi? 3 towers. So we're going to create another class. This assignment's going to be so entertaining because I'm going to give you like all of the pieces of the game partially done. And you're going to hate me when you try to finish it. I'm going to like that. All right, new class. Towers of Hanoi. will be the name of this class. And this guy is going to keep track of 3 towers. So we're going to have a tower array called the towers. This guy will be private. Public towers of Hanoi. Here's our constructor. And we're going to say the towers is equal to a new tower array 3. For int I is equal to 0, I is less than the towers dot length, I plus plus, the towers at bucket I is equal to a new tower. So actually fill up our array with real towers. Let's give ourselves a display method. Now, first, we'll see the problem. I'll create a quick for loop for int I is equal to 0, I is less than this dot, the towers dot length, I plus plus, this dot, the towers at bucket I dot display. So now, we're going to see 3 perfectly built towers, one right on top of each other. Oh, hold on. I'm displaying the wrong thing.
Should really name them shorter things.
Well, that wouldn't be as entertaining. These mean something. So now we see we have 3 perfect towers
On the top of each other?
right on top of each other. And even worse, what? Our game is supposed to have 1 full tower, 2 empty towers to start with. Make sense? So only the starting tower actually has disks on it. The other 2 should be empty. Right? Okay. Well, we can fix that. Towers of Hanoi has 3 towers. Fine. So here's my 3 towers. But each tower was built generically. It just says, fill this guy up with disks. Well, here's our tower. Our tower should take in num disks. Okay? Now, the number of disks that every tower can hold will always be 3 in our current example where we're only dealing with 3 disks, which is what your homework assignment is. So we'll still have an array capable of holding 3. But what will change is whether or not we actually put disks in that tower. That make sense? So what we're going to do here is we're going to say for int I is equal to 0, I is less than num disks, I plus plus. The disks at bucket I is equal to a new disk of what size? Well, the first disk that we put on will be always of size 1. So we'll create a little variable for the current size, start off at 1, put that size disk on there. Then we'll say cur size plus plus. So now we made our constructor for tower take in the number of disks this tower starts with. So Tower of Hanoi, that object, which creates 3 towers, can make our first tower have 3 disks on it and have our second and third tower have 0 disks on it. That make sense? So just to show you this guy working, the towers at bucket 0 is equal to a new tower 3 disks. And I'm just going to make these guys 1 each for right now, just so we can actually see them print, because otherwise it would not print anything, because there would be 0 disks on them.
Okay.
Okay, so we should see a full tower followed by 2 small disks, a double equal sign and another double equal sign. Yep. Everybody relax. Actually, that shouldn't have broken it. Okay. So first one, we have our full tower. Second one, we have our double equal sign with 2 nulls. Third one, we have our double equal sign with 2 nulls. So that means that our tower needs to display itself differently. Before we display anything, I need to make sure that this guy is not null. If this dot the disks at bucket I is not equal to null, then display it. So only display it if there's actually a disk to display. We can still do our spacing here. We're going to change that anyways here in a minute. You'll see why. But we could still do this in theory. But we don't actually want to show that we don't want to show null when there's not a disk there. Okay? Run this now. We have oh, it's just because of the spacing. We're going to change that anyways. But we see that we have no nulls.
Yep.
Okay? Full tower, no nulls. But what we really want to see is we want to see 3 separate towers. A full tower and then 2 towers that are empty. Maybe we'd like to see a little base, like in our game out here. Each one of these has kind of a base to it. Maybe we don't build our stick in the center, but maybe we have a little base that maybe is 10 things across. So with that in mind, if we look at our towers of Hanoi, let's forget about this display method for right now. I might start off by saying system.out.println that's our base. So maybe I say string base is equal to this guy. And then I say for int I is equal to 0, I is less than 3, I++, just for right now. We're going to be changing this. And I'll say system.out.print base followed by, actually let's do base followed by a tab. Okay, this is the character representation of a tab. Okay?
Then it will be in a
It'll be boom, boom, boom.
straight line.
Yep, and then at the very end, I'll do a system.out.println. That'll kick it down a line. So now when we display this, we should have 3 bases. Okay? 3 bases, each tabbed between each other. Now we want to have a tower on top of each of those. We want to have a full tower over here and 2 empty towers. But we want it to look the right way. How would you pull that off? The last thing we're going to display is our base, right? If you think about how these characters go onto the screen, we'll display our top disk across all the towers. Then the next disk across all the towers. Then the next disk across all the towers. Then our base.
Oh,
Does that make sense?
yeah.
Okay, so we know we have 3 towers. And we want to get bucket 0 of each tower, then bucket 1 of each tower, then bucket 2 of each tower. And we want to handle all the spacing here. rather than at the tower level. Okay. So go back into tower. Here's this num space thing that we have there. It no longer makes sense for us to display a tower. Does that make sense?
Mm-hmm.
Does not make sense for us to display a tower. Instead, we're going to write a method. Public let's think how we want to do this to give you the best hint for the assignment.
Thank you.
That'll take me down the wrong path. Okay, we're going to do this. Public disk array get disks. We're just going to write a little getter that gives us access to that private array. So each tower can now provide Towers of Hanoi with its disk array. So Towers of Hanoi can process that guy. All right. So here's our towers. So for I equals 0, I is less than this dot, the towers dot length, I plus plus. So this will go through 3 times in our current example, right? What I want to do the first time is I want to get the first disk from each of our towers. So we're going to say disk array cur disks. We'll say cur disks is equal to this dot the towers at bucket I dot get disks. So we'll get the array associated with the current tower we're looking at. Make sense?
Mm-hmm.
Now, we'll put the tab in here in a second. I want to go through and I want to get each of my towers. I want to get the first disk on each of my towers. Then I want to get the second disk on each of my towers. Then I want to get the third disk on each of my towers. And I want to display that disk appropriately. Okay? Well, this is going to go from tower to tower to tower. For each tower, we want to get 1 disk. Let's see, cur level, we'll start level off at 0. We'll get the disk at bucket 0, disk at bucket 1, disk at bucket 2. That make sense? So here's cur disks. We want to get the disk from that's fine. So we're going to say temp is equal to cur disks at bucket cur level. That gives us the actual disk. Might be null, might be an actual disk. Make sense? If temp is not equal to null, if we are not looking at the null disk, if we're looking at a disk that actually has a value to it, we want to get that disk's toString. That'll give us the number of spaces, the number of equal signs rather, right? Okay. So if it's not equal to null, we're just going to print something out here. We're going to say system.out.print temp.toString. Okay? That's what we're going to do if there is a disk there. And we're going to concatenate onto that. Well, system.out.print won't really concatenate. It'll ultimately have that effect. A tab. We're going to end up adding some extra spaces in too, but just to get it starting to look right. So for each tower, we're going to grab the current disk, then we're going to grab the current disks, then we'll grab the actual disk that we're interested in. Then if that disk was not null, we'll print out its spaces, its equal signs rather, then we'll throw a tab in there to kick us over to the next column, if you will, the next tower. Okay? So we know we need to go through 3 times here. That make sense? For each tower. So the first time through, we will hopefully see, if we just do this the very first time, we should hopefully see a double equal sign followed by nothing, followed by nothing. Because we're not even showing the base at this point. Okay? So if this is working right now, that's what we'll see. Hold on. Tower's not length. Oh, here we need to make those all 0. There's our single tower, our single disk, nothing. Okay? Now we're going to go ahead and have it do another level. Well, we need to wrap this for loop in the loop that goes through all of the disks, right? Which we know is 3. Okay, so for right now, we're going to say int num disks is equal to, we'll just hard code it. Well, we won't hard code it, but we know how our towers is working. Our towers are working. So we're going to say this dot the towers dot at bucket 0 dot get disks dot length. That's how many disks are in each of our towers. Some of them will actually have a disk there, some of them won't. But we know our towers will have the ability to hold that number of disks. This will allow us next class to be able to add in the ability to have towers with 10 disks on them or something like that. Okay? So this is just a generic way of saying 3. In our current example, this will be 3. Okay?
Can you go back to tower for a second, just because I've got another typo and I can't find it. I'm sorry, I can't type as fast as you.
Well, I'll end up emailing you the code in the end anyways.
Okay, just kidding, I was missing another comma or something in your parentheses, but okay, I'm good, thank you.
All right, so this will be 3. So we want to wrap all this other stuff in a for int j is equal to 0. J is less than num disks. J++. So we'll put this whole structure inside of another for loop. This says for each column. Well, rather for each row. So this inner loop goes through for each tower. Give me row 0 for each of these towers. Now give me row 1 for each of these towers. Now give me row 2 for each of these towers. That make sense? So when we get our cur disks, we're going to grab the disks from tower I. We'll grab the temp will be the disk at cur level. where does J come into play here? Well, J is never actually used as an index. It just controls what happens to cur level. So after we kick it down a line, we need to say cur level plus plus. That make sense? Now, we could also just replace cur level with J. See how that's working? J is 0 the first time, then it's 1, then it's 2. So cur level here can be replaced by J. Then we don't need cur level. We don't need cur level. For each tower, grab the disk at position J. Disk at position 0, disk at position 0, disk at position 0. Finish with the towers, loop back around, J is now 1. Disk at position 1, disk at position 1, disk at position 1. Loop back around, J is now 2. Disk at position 2, disk at position 2, disk at position 2. Make sense? All right. Finally, we need to have our bases print out. So we'll do a system.out.println base concatenated with a tab. Actually, let's just do it the way we did it before, so it's flexible for having more towers next time. For int I is equal to 0, I is less than this dot, the towers dot length, I plus plus, system.out.print base concatenated with, and then a system.out.println empty string to kick it down the line. So this will print out our final base. This should print out all of our disks, not necessarily spaced correctly yet, but should print them out nonetheless. Okay? So if we run this, we get our disks here, but we're not sure where the disks will show up over here. Just for the sake of argument right now, if you will allow me, I'm going to go ahead and make those both 1s. Actually, let's make it 1 and 2, just so we can see them all. Okay? See how they're not spaced right yet? This is currently just a tab. We really need to take into account the number of spaces over from each of these. Does that make sense? We need to be able to pad it across. Okay, well, how do we pull that off? If I'm going to create a little function here. Private string get pad string int count. All right, so this is just a quick little function. I pass it a count, and it returns a string with that many spaces in it. So if I passed it a 3, it will give me a string that has a length of 3 spaces are in it. This is for padding. Okay? Just a quick little function that I need to reuse often, hence the purpose of methods, right? Methods are chunks of code that we might need to call multiple times. Well, we're going to need a nice convenient way of getting different length strings for padding. So I wrote a little function for doing it. Okay, now when we print out our disks here, what's our spacing? Well, depends. If you remember back to when we were doing it before, the top level was 2, then it was 1, then it was 0. Correct? So it was length minus 1, or num disks minus 1 was our Kerr spacing, right? Int Kerr spaces is equal to num disks minus 1.
Okay.
That make sense?
Yeah, we'll start from top.
Okay. Now, what I'll do here is before we put our toString in here, I will say this dot get pad string Kerr spaces and concatenate that onto my string. And then we'll say Kerr spaces minus minus. This won't be right yet, but we should at least see that left tower come into alignment. Okay?
That's not reassuring.
It's better than nothing. Okay, so this will be proof that our get pad string is working. First time through, it'll pad it by 2, then it'll pad it by 1, then it'll pad it by 0. But it's only padding the left-hand side of each tower. But we won't be able to see the other ones very well because they have less disks in them and they'll still look way off center. Okay? But our left tower looks a lot better. It's still not padded enough to take into account it's getting centered on this guy. So we need to determine how much more does it need to go to get to that. So this is 1, 2, 3, 4. It'll really depend on how many disks we have. Just for the sake of time, let's just hard code it on there. We're going to give it a space of we'll say indent is equal to 2. That should center it on the first one at least. We'll mess with it more next time when we're making it more generic. I just want to make sure I give you a solid starting point for your assignment. This dot get pad string indent concatenated with this dot get pad string Kerr spaces concatenated with temp. So we're always going to indent by 2 to get it centered over that first base. Now that guy's centered correctly. Okay? But we need to do the correct additional math to get it padded over the other guys. So how much more do I need to pad in order for that guy to get centered? We need to be able to mathematically do this. We know how long our base is. Our base is base.length, number of characters, right? I think we made it 10, but whatever. It's base.length will be the, in case we ever change that. This is the number of tower that we're on, right? Mm-hmm. So 0 times base.length would be 0. 1 times base.length would be 10. 2 times base.length would be 20. So when we indent, what if we say, give me an indentation string, but add to it I times base.length. That'll kick it over towards the right tower. Does that make sense? Still not going to be right, but it's going to be closer to right. Good.
Wait, just a stupid question, but I mean, I sort of when you put like dot length, like how do you know when you need the parentheses after it or not?
Strings always have length, have parentheses. Arrays don't. Arrays, it's a field. Strings,
So fields it doesn't, but
yeah, field is a variable, so it would not have the parentheses.
gotcha.
Other one.
Thank you.
All right, so this should at least pad it more for the further towers. Okay, so depending on which tower I'm currently displaying my disks for, I will multiply I. So sometimes I might be 0 the first time, so it doesn't even matter what the length is. This will be 0. If it's 1, it'll pad it by another 10. If it's 2, it'll pad it by 20. So this should look closer. Okay? Actually, we've sort of over padded. Now, what if I didn't indent here? I don't think it'll make a difference. Just for the sake of alignment, let me just make these all full towers. Okay, so this guy's currently way off, right? All right, so our middle one is buffered too much. Why? Take this guy. These guys are lined up correctly, aren't they? But we start getting out of whack once we get over here to these guys. We'll have to see why here in a second. All right, so the spacing here needs to be what? We're currently indenting again. Then we're doing the multiple of base to kick it over, right? On top of that, we also have tabs. What if we remove the tabs here? Actually, hold on a second. That's fine. Yep. So we're going to take our tabs out. Okay. So these guys, now that we see them left justified, they are padded too much, but these guys are all left justified. And we know how to fix that. We fix it the same way we fixed it here, correct? So we need to pad these guys by less. How much less? This guy right here looks like he's in the right position. He's actually in the wrong position and then just not padded. So he's actually 2 spaces over from where he needs to be. Why is that? It's our base minus our indent. The indent was the beginning part. We used our indent only the first time through. The second time through, our indent doesn't help us. Does that make sense? So what I'm going to do is I'm going to say indent is equal to 0 at the end of this inner loop. But we'll set indent equal to 2 at the beginning of our outer loop. So only for the very first tower will we use an indent of 2. Does that make sense? After that, indent becomes 0. So this goes through our towers. So when we first come into this loop, indent is already 2. That'll indent the very first tower. But the other guys, we're going to remove the indent, switching it back to 0. By doing that, we see now these guys are positioned correctly, just not padded.
Okay.
You with me? Okay. Now, first of all, keep in mind, what we're solving here is a completely stupid problem. It's just an interesting problem. Okay?
Can you scroll down a bit though? I think I have some wrong.
All right. So I need to keep cooking through this so we can get it done. So the same thing that we did
Padding the first.
our pad string for cur spaces, we need to do for these other guys. Now, where is cur spaces changing? It's changing right here. What was cur spaces? Num disks. Now I'm subtracting 1 from cur spaces each time through here, right? This goes through each disk. Each disk needs to have that correct padding, correct? So for disk 0, cur spaces should be 2 in our little example here. So when we print it out, we'll print out a first pad string followed by another pad string for cur spaces followed by our actual temp string. But we have an issue. Our cur spaces pad string works if this is the first time through. It's our first tower. But for our second tower, it's actually too small. Correct? If we look at this, look at the output.
Yeah.
This guy needs to be kicked over 1 more. Actually, 2 more. This guy is just completely out of whack. Okay? So, what are we going to do here? We can take cur spaces and we can do a multiplier by which tower we're currently on. So if I'm currently on tower, where are we at here? If I'm currently on tower I, could I say I times cur spaces? Now what did that do? That broke our indentation here because this is tower 0.
So I plus 1.
I plus 1. Okay, this guy's fixed, this guy's fixed. Now, what about this dude over here? Why is he so far out of whack? Seems interesting that the first 2 appear to be perfect, but the last one's way out there in left field, or right field.
He's angry.
Why is that? Well, as we go through our towers, here's our pad string. It has to do with our multiplier on our base dot length. We're creating a pad string here that is I times base dot length. I is the current tower we're on. Now, what if I didn't do the multiplier? Let's just see the effect. Just always base dot length is our pad. These last guys don't seem horrible, but they're not spaced right, are they? Okay, well, how do I space these guys better? The problem is that our, actually they are spaced fine. We just need to do one other thing. In fact, actually,
start again.
I'm going to tab in front of it. I'm going to move the bases over. Well, that allowed me to scroll farther this way. I got 1 minute to finish fixing, otherwise I'll just upload the current version of the code. And then I'll fix it. I'll fix it later tonight. We're about 10 minutes from it being done. We're out of time. Okay. So in any case, we have something that looks pretty decent. Just the spacing on our very last tower is a little bit off. So let me quickly tell you what I mean, you could even use this. It would look fine for your assignment, at least for doing it. So I'll switch this over to size 0 and 0. Okay, so it's all there. You don't have to make it look more pretty than it is. I will fix it and upload the version of the code, but in case you start working on the assignment before if you start working on it tonight or something, I probably won't fix it till tomorrow morning. It's fine if it displays funny. Okay, so I'll zip up this code and I'll attach it with the homework assignment. So you have your starting point here. Let's talk about the assignments real quick. So the programming assignment is using our stack data structure. So I'm going to give you the entire thing of code. So you're going to have to implement the stack aspect of our towers. Okay? But remember, stacks are actually much simpler than generic linked lists. Because when we implemented our stack generic one, all we were doing is adding to the front and removing from the front and looking at the front. That's by far the easiest part of the linked list, right? If everything we're doing is right around the head pointer. So it should be very easy to implement a stack-like version of tower. Okay? Because you're only looking at the disk at bucket 0 each time. Or the disk at the top of the stack. Okay, so implement the game, the Towers of Hanoi, for 3 disks and 3 columns. As simulated, and I gave you a link to the same place that we were just playing the game, so you can kind of mess with it and see how it works. Your program should use the scanner class for asking the user which column they are taking the disk from and which column they are adding the disk to. So you should have user input. All right, so we should be asking the user, choose your column. So if we choose, just reset this real quick. If I chose column 1, that would pop the disk. Destination column 3, push the disk.
Well, yeah,
Pop the disk, column 1, push the disk, column 2.
we have to give like a disk number and then.
Well, you'd have to give just a tower number
Tower number.
because it'll take the top disk because you're always popping.
Oh yeah.
Right?
Sure.
Does that make sense?
Yep.
So your input, you just ask them which tower are you removing from, which tower are you putting it onto.
Okay.
And then it will implement the rules, and I say that here too. So it should also enforce the rule that a larger disk cannot be placed on top of a smaller disk. Your program should detect when the goal is accomplished, that is, when all the disks have moved over to the right, and display how many moves it took the user to complete. So basically, it should do exactly what this guy does. It just doesn't have to look as pretty because it's all text-based. And you don't have to allow it to change the number of disks. Make sense? Okay. So that's the programming assignment. The paper write a 2 to 3 page paper discussing the stack data structure in terms of how it works, what its 3 specific functions are, so push, pop, peek, and how modern programming languages use a stack to implement recursion. Finally, give an example of a problem for which a stack is the right tool for the job.
Yeah.
Make sense? All right, questions, comments, concerns, bribes?
Nice.
All right, so I will, just in case I forget or something, I'm going to go ahead and zip up the current version of the code. Because worst case, you could do your assignment off of this. It just won't look as pretty. You can tell where the stacks are, right? And then you'll have that to work with. So I'll upload that now, so you have it. And then if I fix it tomorrow morning, I'll re-upload it.
Okay.
Okay? All right. So I will see everybody Next Monday.